Properties of logarithmic function. In previous section, we introduced the log function. In this section, we're going to go over properties of the log function. These are the objective. First of all, we convert log of product, power, and quotient to the expression in terms of individual log, and then we do opposite conversely. And we try to simplify this type of expression, log base a to the power x. You can see that both of them have the same base, and a to the power log base a, once again, it's exponential function and log function with the same base. They are coming together. We try to simplify this. So the first property, the product rule is if you have a log base a, m times n, where m and n, both of them are positive, then this property says this product can be expanded as a sum by giving the log to both of these expressions. The logarithmic of a product is the sum of the logarithms of the factors. That's the product rule or product property. So for example, let's say if you have log 2 times 3, let's say the base 5, then it's actually log base 5 2 plus log base 5 3, using this property. Okay, the power rule is if you have log with the base a, m to the power p, here is the power, you can bring this power in the front and you can write it down as a p times log base am. Keep in mind this property goes from back and forth. You can go from here to here or here to here. That's the same thing. This is called power rule. And finally, the quotient rule is if you have quotient here, division, log base a m over n is equal to log base a m minus log base a n. Okay, the logarithm of a quotient is the logarithm of the numerator minus the logarithmic of the denominator. If you have an expression like this, then because of the same base, the output would be same as the input. This is the input and this is the output. And similarly, if you have the base here and then log the base, same base, the input and output, they supposed to be the same, because log and exponential function are inverse of each other. Okay, so we're going to see some of the examples using this property. Let me just insert some blank pages so we can do some problems here. Okay, so express as a sum of the log. How can you express as a sum of the log? This is the product rule, so you can say it's log base 7 38 plus log base 7 22. That's the product rule. So that is log, just type log base 7 38 plus log base, what is that, 22. Or you can also use this more, and then maybe you can find the log symbol here. No, there is no log symbol. Just type LOG and shift minus sign on the keyboard, and then that's how you can write down log base 7 and then type 7. So check the answer. Incorrect. What happened? Did I do something wrong? Log base 7. Oh, look, here I put the wrong base. It's supposed to be 7, not the 2. So it's supposed to be 7. This is the typo. Excellent. Using the product rule. So that's the product rule. This is the power rule we can use. The power rule is, if you remember from the rule here, this is the power rule. If you have a power p, you can bring that power in front. In this problem, you can express this as a power. You can write it down as ln 8 to the power half, because the square root means the exponent half. You can bring this exponent half here, and then you can write down ln 8 by using this power rule. So simplify your answer, use integer or fraction for any numbers in the expression. Type 1/2, type ln, and then 8. That's the answer using the power rule. So now use the difference of quotient, which is third rule, which is the quotient rule. Log base CQ minus log base C7. That's the quotient rule. Log base CQ, sorry about that, Q, and minus, type log base C again, 7. When you type, use the log LOZ on keyboard and then shift and minus sign on the keyboard. That will take that base, and then type C and then go back to the normal case, normal Q, and then minus. Or maybe you can use where is that base thing on here? You can use this one to type log base, whatever base you need. Okay, so these are the property. We use all the property. Now let's go to, can you rewrite this expression as a sum or difference? Now you have to use more than one property. So because you have 3 different terms, and they are in product, so first of all we can use the product rule. Here you have log base b x to the power 3 times y to the power 7 times z. Keep in mind, you can use the product rule for as many terms as you have. It's not only between 2 terms. So I can expand this as a log base b x cube plus log base b y to the power 7 plus log base b z. Okay, and after that, because here is the exponent and here is the exponent, you can use the power rule. You can bring 3 in the front, and you can write 3 log base b of x, 7 log base b of y, plus log base b of z. So when you type this, use parentheses to clear denote the argument of each function. So 3 log base b, and then use parentheses x plus 7 log base b, once again parentheses y, and plus log base b, and then parentheses z. Using the product rule and then power rule, we can expand this. Here, express as a single log. So instead of, going from left to right using these properties, we would like to go from right to left. So in this problem, you can see you have half log base 10. See the base 10, you don't have to write down the base, 9 log base 10d. So this number half, you can bring it to the exponent, and you can write it down log c to the power half plus log d to the power 9. And now because there is a plus sign, now you can write down log c to the power half times d to the power 9 using the product rule. So it's a 1 log c to the power half and d to the power 9. So that's the problem. Okay, I will go to the next problem. Simplify E, L, and V. Keep in mind, if you have this thing, E is the base, log E is ln, and V. So they have the same base. So the answer is V only, because E and ln, they are inverse of each other. Here, same ln and E, they are coming together, so they are inverse, so they will just cancel, and the output would be same as the input, which is 90. Let me go to the next problem. Determine whether the following statement is true. Assume that a and x are positive. Is it true? So to check that, you can just use the product rule on the right side. If you or left side, the product rule log base a 8x. If you use the product rule, it would be log base a 8 plus log base a x, and which is the case on the right side, and that's true because of the product rule. Okay, given that log base ax is 3, log base a of y is 4, and log base a of z is 5, find the following. First of all, you have to express this as, you have to expand this, and you have to express everything, this expression, in terms of log base ax, log base ay, and log base of ag. So how do you do that? This is the single term, so log base a, and there is a quotient, so you can write it down this as a y square z to the power 4 to the power half, sorry, not the power half, it's 1/3 because there is a third cube, minus log x square z to the power -4 to the power 1/3. Here is the minus because there is a quotient, and then keep going. So if you just keep continue, that 1/3 comes in the front, and you will have log base a y square z to the power 4 minus 1/3 log base a x square z to the power -4. You have to keep expanding this using the product rule. It will be log base a y square plus log base a z to the power 4 minus 1/3. It's log base a x square plus log base a z to the power -4. So we can further use the power rule, and we can say this is 2 times log base a y plus 4 times log base a z, 1/3, 2 times log base a x plus this -4 comes in the front, and it will be -4 log base a z. Now you just have to plug the value of this log base a y and everything. So it would be 1/3, 2 times log base a y is 4 plus 4 times log base a of z is 5 minus 1/3, 2 times log base a of ax is 3, and minus 4 times log base a of z is 5. So we have to simplify this now. So 2 times 4 is 8, 5 times 4 is 20, 20 plus 8 is 28 divided by 3 on the first expression. So I need more pages here. 28 divided by 3 on the first expression. 28 divided by 3 minus, let's go back and check the second one. 2 times 3 is 6 minus 20, which is minus 14. Minus 14 minus is positive 14 divided by 3. Okay, positive 14 divided by 3. So if you add this to number, 28 plus 14 is 42 divided by 3. And then if you divide 42 by 3, that would be 14. The answer is 14. After simplifying everything and then plugging this value, the answer is 14, and that's all for this section.